Hola, buenos días. Bonjour, Karine, Rebecca. Good morning, everyone. Vous me permettez de mots d'abord en español. Oui, merci. Bueno, buenos días. Es un gusto para mí poder tener hoy en este día aquí una conferencia estas de las profesoras que hemos invitado desde la Universidad de Paris-1, en la Sorbonne, que nos presentará un tema sobre la investigación en ingeniería de sistemas de información, que abarca un poco lo que es también la investigación en la ingeniería de software, y creo que esto es un reto importante para nosotros como institución, en el sentido que hemos sido muy fuertes en la enseñanza, en la educación, en la parte más docente, en la parte de ingeniería de software, pero creo que la exposición de ellas hoy nos va a abrir un poco más acerca de lo que es la investigación en estos temas. De igual forma, vamos a ver un poco lo que es la relación con los programas de enseñanza y la estrategia que ha desarrollado la Universidad de París. Así que gracias, voy a hacer la introducción ya formal de las compañeras. Welcome to TEC. Thank you to be here today. Was talking to my colleagues and public on the broadcast that we were talking the previous day that we are very good on teaching and software engineering. We have much expertise, but in some ways we are lack on what research means in that topic. So I'm sure that your presentation will open a little our minds on that topic, because your expertise in the research center was focused for 30 years, I think, or more in that field. So we are eager to learn about you do in France, and specifically in Paris-1. So thank you again. The microphone is yours, so we can start with the presentation. And once again, thank you to the public here in the auditorium and people that are following us on Zoom and YouTube. Thank you.
Okay, thank you very much. And what we said, buenos dias. I'm not speaking Spanish, so I try to speak English. And okay, we will start with this presentation on information system engineering. So it's our research field for many years now. And we have done work to express to you the evolutions of this particular field in the research domain, in order to understand the fact that we evolved during the time, and also where these fields should be, I think 5 years from now. Okay, so to start for this topic, we try to understand what it is information system before understanding the engineering. And you will see that it's very difficult to find a good definition of what it is an information system, because you have different point of view. So we try to summarize for you the different point of view of this particular element, information system, and we will see why we have this particular different point of view, and how we will use it for the curriculum, or for the master curriculum or master degree. So if we take the information system in the narrow sense, it means that the information system could be an artifact, and this artifact could be only technical or informatic. So it's why we call this narrow sense, because you will see the information system only through the technique, And in this case, you can say that your information system could be a set of interconnected applications or softwares. And you can say also that the information system could be a set of IT resource able to collect, store, process, or distribute information. So this is a technical point of view. Of course, if you take this technical point of view, when you call information system engineering, it could be more technical. So it could be software engineering and software development process in this case. But but we have another point of view, what we call broader sense. So in this case, broader sense means that this particular information system, it is an artifact or an object, but it's an organizational artifact, should be integrated in a particular organization. So in this case, you are not considered... Okay, so we can restart. Sorry for the... Oh, il y a un écho. Okay, can you listen to? Okay, so we can restart now that we have fixed the technical problem. So I say to you that you have different point of view according to information system. So the second one, it's a broader sense, what we call broader sense, and it's more. You can see that the information system, it's considered as an organizational object or artifact. And the purpose of this particular artifact is to be integrated in its environment. So it should be support the business process, the business actor, and business goals. So if we have this kind of definitions, it means that in information system engineering, if we take this point of view, you will see that you could have some fields that enterprise architecture, process engineering, conceptual design, business alignment, knowledge and data engineering, knowledge management, security, quality management, etc. So it means that what you will focus on this particular point of view, it's the fitness of the information system to this environment. So this is just to express to you the meaning of information system engineering. Of course, we take the broader sense. So we use the fact that the information system, it's an organizational element, and you have to care about the environment of this element to integrate it. So the presentation will express here the evolution in terms of research in this particular area. So we have made a bibliographic analysis. We will also show you the how research topics. So the theory is our laboratory, and we will see after all how we integrate our research in the master degree.
That's my turn. Okay, so we wanted to have a scientific analysis of the IS field because we know what we are working on, but we wanted it to be a bit more scientific. So we made a bibliographical analysis. So we made it in two stages. The first stage was to identify the key authors in information system engineering. And the second stage was to identify all the topics these key authors were working on the last 50 years. So first step was to identify the key authors. For that, we have been on DBLP, which register all the publications of authors in computing. So in DBLP, we just walk through information systems and we tried to identify all the conferences which were dedicated to information system in a broad sense. So not on a specific area of information system, not requirement engineering conference, for instance, but really conferences in the whole area of information system. And on all these conferences, we just selected the conferences which were ranked in the core ranking as A or B conferences. And on all these stats, we had at the end 17 conferences dedicated to information system engineering in the whole area of information system. When we identified these 17 conferences, we take all the authors on these conferences, and we take all the authors which had more than 10 papers, at least in one of these conferences. We add all the numbering of references in these authors, and we selected at the end all the papers which had more than 25 papers accumulated in this set of conferences, which gave us 124 authors, which we identified as the key authors in this specific domain of information systems. Then we took again DPLP, and we took all the references of these 124 authors to see all the area they are working on, even if it was not specifically indicated as information system. We then use Mendeley as the bibliographical tool in order to update all the metadata of all the references. And then we use another bibliographic tool, which is called VozViewer, which helps us to make a visualization of the area of all the topics we have in information systems. So just the first information was on the number of references we obtain. We cut the results in 4 periods. The first period was from 1971, which was the beginning of information system area in DBLP, to 1999, so it was the first 30 years, and then we take the 10 years after, so 2000 to 2009, the second 10 years, 2010 to 2019, and then the rest until 2023, which is now. And we already can see a big evolution of the number of publications in this area, because in the first 30 years we had 1,300 papers, but then in the 10 years after we had already more than 6,000 papers, and in the 10 years after that we have more than 11,000 of papers. So we may, in the last period, which is only on the 4 years of the period, we had 4,000 papers, and we made a projection. If it's still linearly on the year, we'll have more than 12,000 papers, and if it's still growing like we see in the third period, it will be even more than that. So a lot of research are made on information systems.
Okay, so I try to explain to you the evolutions of the keywords, so of the research topics. So for doing that, okay, so this is the result of VozViewer. And so you have a cluster, and we try to analyze these clusters. So first we try to find information system, because it's the core of the research, of the selection of the papers. And after all, we regard the different topics in this period. So in this period, what you can understand, it's in information system, you have to conceptualize or to model the real world. So the real world, because what we want is to build applications. So first, you have to model data. So it's why you have at this period some some data modeling issues, and you have several models. You have several models. You have also another issue, which could be schema evolutions. So it means that if your models change during the time, what will be the impact? And another modeling used at this time, it was the workflow. So workflow, it's more related on process. Roberto. The second point, it's around the database, because when you have modeling the data, what you should do is to implement it in the database. So database design and conceptual schema, it's an issue at this time to represent what you have in information system. Another topics, it's method engineering. So what we call method engineering, it's the fact that you have methodology, and because you have models and you have methodology to be able to conceptualize information systems. So in method engineering at these times, it should be the understanding of methodology and the formalization of what is a methodology. Another point which is more related to management is information system strategy. So the fact that what you want to do with the information system in your organizations. And you have a connection with cooperative works and group support systems. So we have several topics. You have several works on the fact that if you want to have cooperative works, because information system design is a cooperative work. So how you will use a group support system to do that? If you take, so this is a research topic. Now, if you take the technological topics or topics more related to IT, what we can see, it's at this time, it should be only database, group support systems, and you can say that electronic data interchange, it's more related to IT because it's representing how you can interoperate between applications. So at this time, we are at the data level. If we take the research topic of our laboratory, we are working on conceptual modeling and at the data levels. We are working on the method engineering to understand and formalize methodology at this time. And we work also on cooperative works inside the methodology because conceptual modeling, it's a cooperative activities. But we had also at this time, so this is why it's underlined in the red color. It's a topic we working on at this time, and we are not expressed in the graph. So the topic was requirement engineering and process engineering. So we have working at this particular topic since 1995. And we have a project on that. So requirement engineering and process engineering are strongly related because in our works, we are focusing on how we will represent the requirement engineering process because it's an innovative and creative process. So it's why we have to understand process engineering and formalize this particular type of process. So I made this in red because it's not present in the graph. So we are a little bit advanced at this time in this particular topic. So if we take now 2000-2009, we have another graph. And if we try to understand information system, it's there. So it's not in the center at this time. And what we are already conceptual modeling is still in this graph. And we have also method engineering, but in less importance, yes. Requirement engineering appears and some methods. So at this time, you know, we have object-oriented methods, and we have a big fight between different research work on object-oriented methods, and the winner is UML. So we have now a lot of work on particular method UML. And another point in the methods, it's the agility. So the agility starts at this time also. So you have work on agility at this time. We made this on conceptual modeling because it's related in these clusters. If we talk the data point of view, the modeling is not anymore on data. So what we'll see, it's more about knowledge, about ontology and web semantics, and also about information retrieval. So in this case, what we can see, it's conceptual data modeling. It's not an issue anymore. And what we want about the data is the informations. It's the sense or it's the meanings of this information or of the data. So it's why we are working on this particular, we have worked on this particular field. If you take now the process engineering part, you cannot see process engineering, I think, in the graph, but we regroup some of them as a process engineering. So you have process modeling, you have process mining, software process improvement, workflow management. So workflow now is not anymore a model problems. It's not anymore a modeling problems. It's more a problem of workflow management, workflow tools, automatizations. So in this case here, what we working, it's on the fact that you will have tools to automate workflow. And of course, you have particular orientations. So after the object orientation, you will see the service orientations. And you have some people working on the service-oriented architecture. And of course, they use the web services. What we can see now, it's you have a specific research on application domain. So it's not anymore a research on a general point of view, but more on applications domain. So you can see that you have research on e-government, e-learning, e-commerce, and healthcare. So it means that in this case, the research, it's more dedicated to a particular application domain. So sometimes it's more about modeling, data, or process. It depends on the work. If you take the relation of these topics to IT, so we took IT in a large sense. So what we can see, it's ontology will be tools. So tools, of course, with a model, but also a tool for using and interpreting semantics in data. You have internet, of course. So internet is the tools, and of course, information system research are impacted with this particular tools. Web service, of course. Service-oriented architecture is also related to IT, or it's a technical point of view. Workflow management here, because here it's more tools. So this is the tools built to automate workflow. And we can see that some technical models are used like Petri nets. Okay, so now if we take our research, so we're still working on method engineering and requirement engineering and process engineering as we seen before. And we have also a work on the service-oriented visions with the web services. And we start also with a particular project, a research on an application domain which is e-commerce. So now if we take the topic we currently done in this particular field, in this particular period, which is not present in the graph, you will see that we work at this period on enterprise modeling. So this is you take the information system in the very, very broader sense. So it means that you want to acquire information about the enterprise through models. So you will have models to represent all the activity, all the process, all the actors, and also the strategy and the goal of the enterprise. So this is the purpose of enterprise modeling. And we use also intensively the goal modeling and the intentional goal modeling, if we can say that. And we use it in the method engineering and requirement engineering field. We start also a particular work on context modeling. So context here, it's the context awareness. So it's coming from technical applications, or you want to adapt your application according to a particular context. So we start to work on this particular context awareness, and because what we want is the adaptation of the information system, and we start with the fact that we try to model context and understand context. So in this case, you have two issues. One is modeling the data and capture the data, and the other one is to acquire the semantics of this data in order to have adaptation rules according to a particular context. And what is also noticeable is the fact that in the application domain, we, of course, we keep the e-commerce, but we try to analyze also social media and social networks. And of course, it's also related to context modeling, because the idea is to acquire informations about persons, not information system, but about persons around social media. Okay, next one. So the other period, so 2010 to 2019. So what you can see, it's the graph is more and more important. And where is the information system in this particular graph? Is there. And what we can see, we are still the conceptual modeling with requirement engineering, context modeling, enterprise modeling. So context, it's not only data anymore. It's more the fact that you want to model context, and the data, the data issue are solved at this time. So this is the enterprise modeling, context modeling. We start now with business intelligence. So it's the beginning of the use of algorithm coming from artificial intelligence. So we have big data, data mining, Internet of Things, and process mining. So this is this particular topic, of course, are related to information systems. Enterprise architecture. So it is the first time that enterprise architecture. I think it's when you make enterprise modeling, you know better the enterprise, and now you have issue about how to structure your information system in your organizations. And if you take not only the technical architecture, but the more organizational architecture, what we will work, it's on enterprise architecture. You have knowledge management, which is also keeping in mind, because you have to understand that the information system in company, you need more than what you have in the information system. So you have to keep information around the information system. It's a purpose of knowledge management. And of course, you are always process engineering. So here it's more focusing on business process. So we have also several models, and the winner of this particular work was BPMN. So BPMN now it's the models used for representing business process. And of course, you have issue about these particular models, and you have also to manage this particular process. So in this case, you have the models and the tools. New topic, sustainability, green information systems, coming from this now. So this is transversal topic, and how it will impact the information system and the design of them. Cloud computing, so we will see that we use web services, and of course cloud computing in the generalization of the services orientations. So cloud computing is here to represent how you will integrate services inside your information system. Digital transformation is also a topic, because information system, it's a means to make the digital transformations. And you have also application domain. So what we can see, the social media is appearing, and crowdsourcing also. And you have also e-government, e-commerce, and healthcare, which are all remain topics at this time. Okay, technology. So we will see that there are more and more technology. So you have web service, so Internet of Things, cloud computing, and everything representing what you will use in artificial intelligence, such as machine learning, big data, and data mining. Okay. So if now we regard our research work in our laboratory, what we can say, we are moving on from the context point of view, because we will consider now the IoT. IoT as a device capturing data coming from the environment and helping us to acquire data context. So it's why we will use IoT. Enterprise architecture, we working on that, because we are working on enterprise modeling. So it's the same package. And of course, cloud computing, it's also related to context modeling and IoT, because what we would like is to adapt information system, not only at the business level, but also because technical elements will change. And cloud computing, your services, you use services inside your information system, and some services are down or moved, and you have to change, of course, the information system, how it works. So we're still working on social media. And what we work, which are not present in the graph, we are working on a software product line. So this is a particular topic related to requirement engineering, because it's the fact that your software, it's it's a set of variation, if you prefer. And when you want to use this particular software, you have to configure it. And of course, it's a problem of implementations, but related to the requirement, because you have to adapt this software according to the user requirements. We work on pervasive information systems. It's a combination of context management, IoT, cloud computing, and we federate them in what we call pervasive information systems. So we will see later the definition of pervasive information systems. And what we can say, it's we work on process modeling and intentional process modeling. So we will see that with Rebecca. And we had at this time blockchain, because we work on the blockchain and how this blockchain can be integrated in information systems. Last period, so the 4 last years, we have information system there, and what we can say, it's conceptual modeling, so requirement engineering, ontology, and agile software development are still in the graph. Artificial intelligence appeared, and you have a set of keywords: big data, machine learning, deep learning, text mining, Internet of Things, and process mining. We put Internet of Things in artificial intelligence because we use it. And when you use it, it's because you capture data, and it's a way to capture a lot of data. Enterprise architecture, process engineering. So this is the same topics as before. Sustainability is there. So blockchain is now there. And of course, with blockchain, the topic we connected, it's the trust. So trust, it's a particular topic. And of course, if you want trust between organization or for a particular service, you can use at the technological level a blockchain. Digital transformations, and you have application domain. So what we can see, it's you have a new application domain, COVID-19. 19, sorry. COVID-19. And so you have a particular work on that, and particulars on the fact that what will be the impact of this particular crisis in information system, in our work, in the users, in the actors, in the organizations. So you have a lot of work on that particular topic. If you took the relation with the technical elements, I think we did it. It's the same as last time. Ontology, big data, business process management tools, blockchain, IoT, machine learning, and deep learning. So we don't put research on that particular techniques. We use these techniques to be integrated in the information systems. So the purpose, it's more to understand these techniques and to adapt to have a particular research on how to integrate these particular techniques in the information systems. From the research, we work on, I think it's the same as before, blockchain, trust, yeah, I think we have nothing new. And the new, it will be in the red one. Software product line, context management, smart life. So we had from the previous period, smart life, and e-learning. The other are still remain still existing in the periods. Okay, so this is for the evolution part. So we try to show you how the research topic are evolving during the time, and we split it in 4 or 5 periods. Now we focus more on what we done in our laboratory. So we select some topics, and briefly we try to explain to you the purpose of this research in this topic. So first, we see that we work on requirement engineering, and particularly on software product line. So the purpose of this topic, okay, we build various tools. So this is a tools to help in configurations, to model product line, and to make to help in the configuration of a particular product according to user requirements. So the topic here, the main topic is to help to find the appropriate configurations of a software product line according to user requirements. And of course, what we can see, it's what you want is not what you get, because you have conflict. You have some variant conflict inside the product line. So sometimes it could be very difficult. And the better example for that, it's a car. When you want a car, you have it's a big product line, and of course it's not software, but it's a product line, and we can see sometimes if you want a particular options, but you cannot, because you don't have enough space to put it, because you select another options. So this is the purpose of this research. The second, it's more about Rebecca.
Yes, we work on requirement engineering for quite a long time, and on software product line, but also on the rest of requirement engineering. And what we can see for these last years is that we have another kind of requirements which appear. We already have functional requirements, non-functional requirements, but now we see some other kind of requirements which is more about the well-being of people, which means that when we develop an applications, we have to take into account what the application has to do exactly, what the requirements of the user are, but also if these requirements take into account the sentience way of doing. The sentience means that you take into account the sentiment analysis of all the people who will be using your applications, in order to see if it's done correctly, if it take into account all these subjective things that will help the user to use the application. And it leads into another field which is called the smart life, which look about this area of all the smart application which exist, smart cities, smart home, and so on. And when you look at these fields, when you look, for instance, in smart cities, because it's one of the first which has been developed, it's all about techniques. It's all about using IoT data, Internet of Things, sensors and devices to take big data and use this data in order to make this development of applications. But now we have a lot of works in smart cities, smart home, a lot of in smart healthcare, for instance, which take into account the well-being of the users. Not only what the system has to do, but also how it is perceived by the users. And in smart healthcare, there's a lot of works on these fields. So we call that the smart life applications. And we have this smartness degree, which increase about, first we have the smart level, where you will find all the usual sensors and device. And then you have the intelligence ones, which take into account a bit more of artificial intelligence area. And then you have the sentience one, we will take into account the sentiment and well-being of the user. So it's a new area where we are beginning to work on at the lab.
We select another topic. It's more related to trust and blockchain. And the idea of this particular research topic, is to help people to integrate blockchain inside their information system according to the user requirement or the requirement they have according to the trust, because sometimes when you use blockchain, it's because you have trust issue about them, about data, about services. You want to share information around the organizations and you want to trust this data. So you will use these blockchain techniques. So here it's more about the fact that you help to configure your blockchain according to your environment and to your requirements. So this is the first step. The second one, it's more about the fact that we want to implement in that blockchain process, business process, which is more about it's a business process element implemented in the blockchains. And what we want to work, it's about the trust. And we try to understand the trust, the various degree of the trust, and how we will integrate it in the blockchain and configure it. Sorry. The other topic, it's more about pervasive information system. So what we call pervasive information system, it's an information system where we integrate in the information system the management of the infrastructure. And so the infrastructure, it's IT resource. So IT and device inside the definition of the information system. And the idea is to have a pervasive information system, because you have knowledge about the resource, about the data of the environment, the data of the resource, and you can get all the information of that and adapt your services, adapt your application, or adapt your management rule according to this data you collect in the context. So it's why it's related to context management, to IoT. And the purpose of that is the adaptations or self-adaptations of the information system to real situations, because you detect through information to collect data with IoT. And of course, it's related to artificial intelligence and machine learning, because we will get a lot of informations, and you have to filter them. So you have to analyze them automatically in order to understand the situations, the real situation of your organizations, in order to adapt. So here the adaptation, it's not only technical adaptations, it's also business adaptations.
Okay, another topic we are working on is process mining, and more specifically intentional process mining. Actually, when you look at process mining, the meaning of this, the work in this area, is to take all the logs of the business activities. So when the user is doing something on this computer for a specific process in the company, it's registered in the computer. And then we can put all these activities in a specific log base, and you can run some algorithms on these logs in order to identify the behavior of the computer. So it helps you to discover automatically the process models that are used by the users. not a prescribed process models, but something which is really used in the reality by the user. So you identify, for instance, BPMN models directly with the logs. So what we are doing at the lab, it's to not just create BPMN models, which are activity-oriented models, but intention-oriented models, which means that instead of saying you have making one activity and then another activity, it's to look about the why questions you have behind the fact that you are doing an activity. It's you have this intention and then you will have this intention after that. It's what we call intentional process models. So we have this discovery of process models, intentional or activity-oriented. And when you are discovering this activity, it helps you to make a recommendation to the user, because when he's doing this work, his activities, he make a first activity, then another activity, and then you can use the models you have identified to say to him, okay, 80% of the population who have been doing these two activities then have made these other activities. And then you can recommend activities directly at runtime to the users. And of course, when you choose one activity, it gets done into the log base, and you have a circle of recommendation and usage and recommendation and usage. That's all. Okay. And another area we have, it's about all this contextual data we have that we can use in social media. For instance, we had work which has been made on Facebook, on Twitter, X now, and other forums, networks, in order to use all this data in other domains, in order to help a user to do things. For instance, in e-learning, it will help the students to have a better training by looking at what they have done and what they are saying, for instance, in forums, in order to recommend them some new activities or to help them to have better marks at the end of the year, for instance. So it use a lot of techniques, like for instance, we have sentiment analysis that we can use on this social media in order to see what happens after that. We also use it in process mining because we mixed the logs, the activity logs that the user are generating with also the context which is around this user in order to have a better recommendation when we try to recommend the next activity or the next intention after what they are doing at this time.
Future? Yes, of course, future. So we try to show you the future, and for us, the future it's of course by using context data and perhaps some algorithm analysis algorithm coming from artificial intelligence, but I think the purpose of the challenge for information system and also I think on software development is a societal challenge about sustainability. For us, it's now a topic, and also regulations. I don't know the terms. It's about the law, about the fact that enterprises are under pressures around the environment by societal challenge, sustainability and regulations. And of course, the information system should support the enterprise in this particular topic. So it means that information system, support the actors in their process at the business levels. So I think this, from the research point of view, is done. But now the purpose is to understand that information system it's also an organizational element inside the enterprise, inside the organizations, and of course, the organization and the enterprise should take into account more problems are more general problems like sustainability, sentience are for me the purpose of also sustainability, and regulations. And regulation is also a big problem, I think, yes. So for us, I think for the information system engineering field, it means that when you want to develop information systems, you care about the functional and non-functional requirements, for sure. But you have to take into account more general point of view that the business of the organizations, it's also the societal challenge coming from and pressing the organizations. So we have to take care of that. And of course, we use it. We we use the field is to make adaptation and self-adaptations. So for us, it's also the topic we care about a long time ago, but we try step by step to work on this particular axis. Because this is closed for the research topics and research we done in our laboratory. So now we can move to the last point, which is about the master degree called MIAGE. So if we try to understand MIAGE, I think we try. So of course it built around the information systems, and we try by these particular slides express to you that if you take the narrow sense of the information system, you are more related to computer science degree. And what you have to learn is how you will construct complex system and complex information systems. And of course, if you take care about the broader sense, you are more related to what we call information system management. So it's more a business degree, management and degree. And the master MIAGE, it's in between because we care about the narrow sense. So it means that we have to understand how the technology evolve, how we will construct information systems. And of course, we care about the broader sense also because this particular IT complex element, it's also an element should integrate in the organizations. And so we have to take care in our degree or in our curriculum the two view. And why we try to keep the two view, it's because we will see that the broader sense has an impact. The impact of the environment on the way of the IS is designed and developed. So this is this particular item here. Of course, it's the environment of your information system should be taken into account when you want to design an IT solutions, but because otherwise your solution is not used by the organizations or by the actors, even if it's the better technical element. And the other things, it's the techniques push the business, and we have seen during the time this particular element. And of course, what we can see, or we will see, it's artificial intelligence, technology will push the organizations, the business of the organizations. Of course, we have IT ethic problem, deontological problems, but it's push also So the impact of the technology on the information system environment, it's what the enterprise want to see when we speak about enterprise. So this is the foundation of our visions in Miage, and it's a vision we have 15 years ago, and we keep it. If we take now, so this is the integrated vision of information systems, and what it is very popular in France, this particular degree, because they have graduate students multi-skilling, and they appreciate that. If you take now how it works, or how the curriculum is built, it's a particular position because you have 3 years of study, and we take last year of bachelor plus the 2 years of masters. And this is not common in France, so we try to keep this particular specificity. And of course, common ground on software development and information system engineering is the purpose of the 2 first year. So the last year of bachelor and the first year of masters. And the 3rd year, so the 2nd year of master, is built with research and also enterprise practice. So it means that each teaching modules in the last year should combine enterprise practice and research dissemination. So it's why we present that. So we have training by research and training for research. It's a common ground in the master level in France. And so we will see that here you have the training for research. So it's a normal situation for research masters. And here you have training by research. So here you have all the module of the information system engineering masters. And in this particular module, we combine enterprise practice, what is currently practice in the enterprise, and what the research works, or what will be the challenge, the issue at the research levels. So they can combine the fact that there are a particular level of practice in the enterprise, and what will be the next of this particular topic with the research disseminations we done. Okay, last point. This particular curriculum, it belongs to an ecosystems, if we can say that, where you have the laboratory, you have the laboratory is here, the curriculum is here, and we have a strong relation with the enterprise, because this particular curriculum is the students are in apprenticeship or in internship. So we have a strong relation with the enterprise. And of course, the enterprise integrate fund, because with the apprenticeships, we have financial support from the enterprise. And they belonging, we have a quality improvement committee each year, and inside we have enterprise. And of course, they can also be partners, and they sometimes are involved in the teaching. If you take the relation between the curriculum and the labs, it's very, I think it's common. It means that we have research disseminations inside the curriculum. It means also that we build a training for and by research. It's very attractive factor that we do that. And of course, from the laboratory, it's very convenient because we can have feedback, experimentation in the enterprise, and master's thesis related to what we have disseminated during the course. Okay, after we have exchange and research collaboration outside, but it's common, we cannot say that. And of course, the bidirectional relations could be also with the enterprise and directly with the labs. So we made also collaborations between enterprise and the labs. I think this is the last one. Okay, so this is just for summarize what we've done in the presentation. So we speak about information system engineering. Of course, we have to take care about the narrow and the broader sense of what this is an information system. You have seen the evolution of the topics, research topics inside these particular fields, and how we make dissemination inside the degree. Thank you.
Thank you so much, Karine and Rebecca. Adding something to the summary, as you could see on the presentation, no matter this is a basic the definition of information system as a start point. What is important for organizations, for social impact, etc. Of course, technologies method will evolve as a nature of technologies, but we have to be aware of the evolution for the purpose of the objective of our information system, how to add value to organization, to our life, etc. So in this from this point of view, I think we can focus on some methodologies, on some techniques, or some technologies, but we have to evolve from the experience of the research center at Paris. We can integrate other in the broader sense of the information system, how is valuable for people and for organizations. And this awareness of the lab is very important to learn from them, and how they include topics that even the more experienced authors haven't included on its research. So we are open to Q&A, to questions from either YouTube, Zoom, and participation here in the auditorium. And thank you once again, Rebecca and Karine. You can post the question on the Q&A or raise your hand for participation by Zoom.
You will come to Paris to make your master's?
So you have no question. A recall for my colleagues here, and we are engaged in a double degree program, and so we are reviewing the agreement for continue our collaboration, but cooperation, but also we can speak for other ways to cooperate by internship of academics or students that want to learn how to research on that kind of topic. I think is very important for us to open our academic activity on software engineering to do more research on that topic. But we are continuing to work during the week. This week we have Karina and Rebecca as a visitors here at Tech. If you have any question, you can look for me and send me your. Okay. It's told me the. Okay, microphones are now open for Zoom. If there is someone that wants to participate or make any question. If not, we thank you everyone here on YouTube and Zoom for your patience and for, I'm sure the cooperation between the University of Paris-1 and Tech going to be fruitful in the future. I don't know if you want to say some last words.
We are open about subjects and open about topics research. I think we are visiting you on the spirit to help you to have a collaborations and to spread the fact that information system engineering, I think it's an important field.
Well, thank you so much. Have a nice day and the rest of the day. Thank you for coming and to be online and watching the conference. Thank you. See you later.
Thank you.
Thank you.